All right, proof number three. Okay, so let's jump into number three. Again, think about our process. First thing you have to do is make sure we have a clear sense of what we're trying to prove, and then try to figure out what in the world we have to try to prove it. So here we go. We have triangle ABD, which is this guy right here, A swinging down to B over to D. We're trying to prove is congruent to triangle ACD, so that's A down to C swinging over to D. Which means if we're proving triangles congruent, we should immediately go in our head to the conditions for congruency, which are side, 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 angle, 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 side, and side, angle, side. Now, if that part's getting repetitive, good. It should be repetitive. That's how you memorize things. So if we know we got to meet one of these conditions, let's examine our givens and decide what in the world we've been given to actually prove it. Well, immediately I see that we've been given some side lengths. AB is congruent to AC. So AB, boom, AC, boom. And then we have AD bisecting BC. AD bisecting BC. So AD bisecting BC means that D is got to be the bisector. By definition of bisection, that means these sides have to be the same. So immediately if I look at what I've been given, I have a side length that's the same, another side length that's the same, which means I'm not going to use ASA, I'm not going to use AAS, I'm going to use either the side, side, side or the side angle side. So we have to kind of determine, well, what information can we now determine from the diagram given the knowledge we have about like vertical angles and that kind of nonsense. Well, if I want to prove side angle side, that means I'd have to prove or be able to justify those two angles being congruent, the ones I just drew. I'll redraw them in red in case you missed it. So I have to prove that the angle at B and the angle at C are congruent, at least have a reason why they are. Now, I think I could actually do that. And the reason I have to do that has everything to do with these sides being congruent. Base angle theorem states that within a triangle, which ABC, even though it's split down the middle, is a big triangle, if these sides are congruent, then that means these angles have to be. Now, I don't think that's our only option, and some of you guys are probably at this point saying, Mr. Collins, wait, whoa, whoa, whoa. How would this guy in the middle? How about he just use reflexive on this guy in the middle? Well, that would be an option too, and I think an equally good one. That's not the way I'm going to take it, and the reason why is simply because I saw base angles first. But that's actually the wonderful part about proofs. You can prove them multiple ways. So before we proceed further, I'm going to rename these angles angle 1 and angle 2. You can rename them whatever you want. You don't have to rename them at all, but instead of having to refer to this angle as ABD and the angle at C as ACD, I'd much rather just call them angle 1 and angle 2 and go about my merry day. So let's put together a little proof plan, a little brainstorm, if we will, or I'm sorry, an outline, if we will. So I want to prove these triangles are congruent by side angle side, triangle congruency theorem. So where am I going to get the stuff? Well, one side is going to be actually just handed to us. It's going to be given. The angle is going to be the result of, that's an A, of the base angles theorem biconditional, which I'm just going to abbreviate. So that was base angles theorem biconditional. And then I have the third side, S2, which is like that BD and DC. That's going to be the result of the definition of bisector. So that's going to be my general plan. One side should be given. One angle is going to be base angle theorem. And then the third angle is going to be definition of bisector. So if I can prove those things, bam, I got myself an actual proof. So let's actually now lay down the final draft, the revised copy. At this point, especially if you watch the last two videos in a row, you realize there's now some different choices in how I'm going to write my proof. For this one, I'm going to just kind of emulate my plan here, and I'm going to write this in a flow style. So here we go. So to prove triangle ABD is congruent to triangle ACD by side, actually, let's do this quickly. Since I have colors, I'm going to use them. Okay, so by side angle side, one side is going to be given, so let's actually officially name that. And we have the given up here in our statement. So the given is AB is congruent to AC. And the reason we know that is because it was actually just given to us, which is a viable way to justify a statement like that. The angle was going to be the result of the base angle theorem. Okay? So we can say that angle 1 is congruent to angle 2 because of the base angle theorem. Wow, my handwriting is terrible. Let's try it again. The base angles theorem biconditional. Okay, and that was in our notes from yesterday. So if you're not familiar with that one, please go review. And the last side we said was going to be the result of a bisection. So let's conclude a couple steps. So D, uh, so we can say that AD bisects BC because it's been given. And because AD bisects BC, we know, and visually here it is right here. So that's a bisector. So we know that BD has to be congruent to DC. So BD has to be congruent to DC. And that's because, man, look at that. That's just having a rough go of it tonight. Okay. BD. And that's going to be because of the definition of bisector. Okay. Now, being a flow proof, this statement leads directly from that statement, so I'll put an arrow. So, if this is true, and if this is true, and if this is true, that tells me the triangles have to be congruent. So triangle ABD congruent to ACD. And the justification is because of side angle side triangle congruence theorem. Okay, and then I'll mark this as QED, and then Bob's your uncle. There you go. So let's review really quick. So I want to prove triangles are congruent, which means I have to meet one of these four conditions for congruency. Um, Looking at the given and starting to mark the diagram, I was given one side, S1, right off the bat. Because AD is a bisector of BC, that means the bottom is cut into two congruent parts, which gives me side 2. And then I noticed because S1 and S1, the AB and AC are congruent, my base angles 1 and 2 have to be congruent also. And so that's going to help me meet the SAS triangle congruence theorem. I could have used side, side, side. That was an option too. I think an equally good one, but that's not the direction I went. So I laid down a really, really quick plan. One side was going to be given. That was going to be my A, B, and AC. One angle is because of the base angle theorem's converse, and then the other side is going to be the result of bisection. So now I'm refining my proof down here. And even though I have really messy handwriting, this flow style proof is a legitimate, totally legit kind of proof to write. I just have to individually kind of prove each part. So side 1 in purple with my given sides. And again, I have to name it. I just can't say, well, these lines are congruent. I have to name them, which is why naming is so important in geometry. Angle 1 was actually a direct statement too. Angle 1 and angle 2 are congruent because of base angle theorem. Again, we're shortening our proof. Because those sides are congruent, A, B, and AC, that means these angles are congruent. We're throwing out the if and then we're keeping the then. Side 2 is a little more complicated. We have to first establish that there was a bisection because it was given to us. And because it was bisected, boom, BD and DC are going to be congruent as well. The arrows indicate that I'm combining those three pieces of information so I can make my final claim that ABD is congruent to ACD because of side angle side, which I clearly met above. QED marks the end of my proof. Boom, we're done with proof number 3.